Okay, so you've started with sequences and series. Okay, all right. So what I'm going to do, yeah, so, there we go. Good, Shailene. I'm so glad to hear that. Now, I hope that what I'm going to do this lesson is not going to jump too far ahead. And I hope I'm not going to leave anybody behind. So let's just see how it goes. Obviously, those of you that are, okay, so iPhone, you've just started series. Okay, so you've already started summing. So all of this is already known to you. Okay, all right. Okay, so you're writing a test already, Rama? Sure, that's crazy. Hello, David. Yes, I know. It's amazing. It's so nice to see you. The other day, I was actually asking if there was anybody else because it was Nizole, who was also in grade 10 with Watobe, and now you guys are in grade 12. It's crazy, isn't it? Welcome, David. It's so nice to see, well, not see you, but yeah, be here with you again. I hope it's going to be a successful and a happy year. Okay, we wrote a test on number patterns and functions. Okay, so in Koneza, your teachers do not mess around, do they, if you're already writing tests? Okay. All right, so at least I've got an idea of where everybody is. Of course, if I say anything that doesn't make sense or you need a bit of extra help, please do ask Yolanda and I. What I'm going to do is, yes, I'm going to first of all start off with arithmetic and geometric term formulae. And then in our lesson on Thursday, I'm going to talk about the sum formulae, right? Because it's really important for us to understand the difference between the formulas and which formula to use in the correct situation. Because of course, if we use the wrong formula, we're not going to get any marks, even for substitution. Okay, so we've got to make sure that we are using the correct formula. Yes, I will. Okay, iPhone, I will definitely do that. You must just tell us your name so I don't keep calling you iPhone. Okay, so an arithmetic pattern, all right, takes the form Tn equals a plus n minus 1d, just like I've got here on the right-hand side. And all arithmetic or linear number patterns are exactly the same. All right, so here A represents the first term in the pattern. Okay, D represents the same thing that all linear number patterns have. Does anybody know what that is? What do all linear or arithmetic patterns share? They have a
common difference.
A common difference, absolutely. Okay, so the difference between the terms is always the same. What does the letter N represent? What does the letter N represent? Sorry, I'm struggling with my eyes a little bit. That's it, the position of the term. Lovely, guys. Well done. Excellent. Very nice. So the position of the term, and what does Tn represent?
Term number.
Not the term number, Letu. It's actually the value of the term. It could be the last term in Kateko. It could be, but it's the actual value of the term in that particular position. Okay, so the value of the term in the nth position, in whatever position it is. Okay, so just very quickly, I just want to explain to you where this pattern comes from, right? And then we can have a look at some of the questions that are involved in working with this pattern. So it's important to note that all linear number patterns, okay, are actually called arithmetic sequences. For some reason, we called them linear number patterns in grade 8, grade 9, grade 10. And then when we get to grade 12, for some reason, we change the name and we start calling it an arithmetic sequence instead of a linear pattern. The other thing that's important to note is that all of these will eventually simplify to Tn equals Bn plus C, and you must simplify it down to that form when they ask you for the general term of the pattern. Right, so in grade 8 and 9, we only worked with this, and then in matric, our teachers introduce us to Tn equals A plus N minus 1D. Some of you may have been introduced to it before, but really speaking, it's only something that we should be given in matric. Okay, so where does this come from? All right, so very, very quickly, imagine we have a pattern that goes 3, 5, 8, oh, sorry, 3, 5, let's make it a little bit more exciting than that. Hang on a second. 3, 8, 13, 18. So if I say I have an arithmetic sequence, 3, 8, 13, 18, what I am saying is that term number 1 is 3. Term number 2 is 8. The term in the third position is 13. The term in the fourth position is 18. Okay, so these are my ends, my positions of the term, and these are my t ends, the value of the term in that position. I can think about this formula over here, this one that I've been working with in grade 8. I can think about it in a different way, all right? So in other words, what we do is we write that term 1, we give it the letter A, and in this case, its value is 3. Term number 2, let's just move down, is A plus, it's also one difference. The difference between these terms being 5. Okay, so remember to work out a difference, a common difference. We would say term 2 minus term 1, or we could say term 4 minus term 3, as long as it was the next term minus the previous term, we're going to get the same answer. All right, so in this case, actually, I must be careful. That's, well, mine just because it does equal the same thing. But anyway, we're going to end up with 8 minus 3. So our difference is going to end up being 5. So in order to work out term 2, we've got 3 plus 5, which is where our 8 comes from. If I now want to work out term 3, it's A plus a difference plus another difference. So this gives me 3 plus 5 plus 5, which is 3 plus, oh, sorry, 3 plus, let's just do that a little bit better. So it's 3 plus 2 groups of 5, all right? So that's 3 plus 10, and that is where my 13 comes from. So can you see here that depending on what term number we are working with, we've always got one less difference. So term 1 has no difference. Term 2 has one difference. Term 3 has 2 differences. All right, so how many differences would I have to add for term 4? How many differences? Exactly, I'd have to add 3, quite right. Okay, so term 4, I'll just pop it up over here. Term 4 would be the equivalent of A plus 3 differences. All right, so I would say A is 3 plus 3 times whatever my difference is, which in this case is 5, and that's how I'm going to end up with 18. So can you see where Tn equals A plus n minus 1 D comes from? Okay, so it's just another way of thinking about something that we actually already know. Okay. So that is the nth term for a arithmetic sequence. Let's just talk very quickly about determining the nth term for a particular arithmetic sequence. Okay, so let's pretend that we have got the pattern 3, 5, 7, and 9. What I want you guys to do is I want to see whether you can determine the nth term of this particular sequence, right? So over here, if they ask me for the nth term of this sequence, what I would then end up doing, let me just clear a little bit of space over here. Is this. So if they wanted the nth term of this pattern, I would say that Tn is equal to A is 3 plus n minus 1. And in this case, my difference is 5. So I'm going to distribute my 5 into the brackets. So this gives me 3 plus 5 times n is 5n, 5 times negative 1 is negative 5, and then I have to simplify it. So I'm going to bring the n term to the front, and 3 minus 5 gives me -2. Okay, so that's how you would find the nth term using a plus n minus 1d. Everybody good with that? How are we feeling? Shorby, go for it. Ask a question.
Hi, ma'am. Can you hear me?
Yes, I can hear you. No problem.
Ma'am, I just wanted to find out if you can just, okay, because in class we used the Tn is equals to Bn plus C. He didn't let us
Yes.
use the other
Oh,
method.
really?
Is it
He didn't
okay?
let you use the other formula. Oh, that's really interesting. Okay. So if your
Yeah.
teacher is insisting that you use Bn plus C, Shlobi, there's nothing wrong with that. Then you're literally just doing it the same way that you would have done in grade 8, grade 9. Okay, where you would have worked out the difference becomes your multiplier, and then you can go and sub in to work out what C is. Okay, no
Okay.
problem.
Thank you so much.
All right, it's a pleasure. Okay. All right, so Amina, you're asking, how do we get 5n? Amina, remember we're distributing. Okay, so we're saying 5 times n. All right, so here this 5, we've got to multiply it by n to get 5n. Okay, and then we've got to multiply 5 by minus 1 to get the -5. Okay. All right, we'll come back to that. I would like you guys to try this question over here. All right, I know it says example number 1, but I think you guys are smart enough to be able to do this on your own. So you've been given an arithmetic sequence. I would like you to determine the nth term, and then I want you to tell me what the value of the 50th term is.
I'm sorry, Teacher Leah, can we go to the previous questions? Offensive just wants to take a screenshot quickly.
Oh, yes, with pleasure, with that.
Yes, yes, but the questions. So,
Oh,
yes, like that.
oh, like that. Okay. Are we all good?
Offensive, hopefully we are good now.
Nomfundo, I'm just showing you how you would get the rule. Okay, we're just talking about arithmetic patterns in general. If they ask you for the rule, then you would get the rule. So if you have a look at this question over here, they've said to us, determine a formula for the general term of the above sequence. So here they want the rule from us. Okay, and then they want us to find the value of the 50th term. Okay, so I'm going to give you guys, I think 3 minutes should be okay, and you're welcome to put your answers into the chat. If you've got any questions, then please do ask. Lovely. Good job, everybody. That's it. Okay, quite right. So we should be getting that. Well done. And then when we want to work out the value of the 50th term, we can go term 50. And of course, we can sub it in here or we can sub it in there. It really doesn't matter. So 2 times 50 plus 1, which gives us 100 plus 1, which is 101, which is what most of you have popped into the chat. Absolutely brilliant. Okay. Big thumbs up to all of you. You guys are brilliant. Very, very nice. Okay, so what I'm going to do now is I'm going to jump back and I'm going to go and talk about exponential or geometric patterns, okay, in comparison with what we know about arithmetic patterns. So exponential or geometric number patterns have a general term, Tn equals AR to the n minus 1. All right, so like we use the words linear and arithmetic interchangeably, we can use the words exponential and geometric interchangeably. Okay, and I don't know if you remember last time I had tried to show you how a quadratic number pattern is similar to a parabola, and in the same way over here, this is going to be similar to y equals, I don't know if you guys remember this from last year. Sorry, I wrote a D, I meant to write an A, B to the X. Okay, so in other words, our N is an exponent. So this is our exponential function. This is our exponential or geometric number pattern. In the same way, this linear number pattern is written as y equals mx plus c. Okay, so your constant difference, your multiplier, is your gradient. And what would be your y-intercept, okay, is what you would then need to take away, your c term over there. Okay, so when it comes to geometric number patterns, let's have a look at some of the similarities and some of the differences. Now, I see there's a mistake there, but anyway, we need to correct that. Okay, so A represents the first term, as it does for arithmetic patterns. And then over here, there is a mistake. That's supposed to be R. Anybody know what R represents? What does R stand for?
Constant
Common
ratio.
ratio.
That's it. So you can call it the constant ratio or the common ratio. That's fine. Absolutely. Good job. N again is the N represents the,
Let's go.
what does N represent?
Position.
That's at the position of the term. Wonderful. Well done. And Tn represents the value of the term. Okay, so the value of the term in that position. Okay, so now let's think about a geometric pattern. All right, so if we have a look, let's say they give us 2, 6, 18, 54, and they tell us that they want us to determine the nth term. Okay, so we're going to determine the nth term. Okay. That's it. So in this situation over here, we can see that term 1 is equal to A. We need to work out R. Now, when we worked out D, our difference, that was term 3 minus term 2, or term 10 minus term 9. When we work out our constant or common ratio, how do we do that? How do we calculate what our constant or common ratio is? Now we don't have a constant difference. That's it, Lobby. Good job. Okay, so now we have to divide. Okay, so in other words, we get 6 divided by 2, or 18 divided by 6. And in this case, we get the same answer. We're going to end up with 3. All right, so there is a constant ratio because each time as we go from term to term, we are multiplying by the same value. Or if you look at it as term 2 divided by term 1, if I go back that way over there, I'm dividing by the same number each time. Okay, so determining the nth term in this situation, we would say Tn equals A. A is equal to 2 times 3 R to the power of n minus 1. Okay, if I do this, is this okay? What if I go, okay, so therefore Tn equals 6 n minus 1 to the n. Is that okay? Am I allowed to do that? Good, good. No, I'm not. Okay, so if I do that, I'm wrong. I'm not allowed to do this. Okay, why am I not allowed to do that, Matrix?
Exponential rules.
Exactly, Phoebe. Okay, so because my bases are different, I'm not allowed to add my exponents or multiply those together or whatever the case is. All right, so I've got to leave it as 2 times 3 to the n minus 1. All right, lovely, well done. So we've determined the nth term. Let's go down and have a look at this. Okay, so now again, your challenge is, I have given you a geometric sequence, and I want you to determine the general term, and then you're going to find the value of the 15th term. So you can go and do that now. Pop your answers in the chat when you've got one. All right, ready, steady, go. So let's see what you guys are popping in the chat. There we go. That's all looking very nice. Well done. Good job. Okay, so iPhone, you've said 3 to the n minus 1. The other answers there all seem to be okay. I'll go back up there now. Here we go. There we go. That's it. So just careful with rounding. Darren, that's correct. Well done. Yes, 100%. That's it. Okay, so just remember that you've got to round correctly. Okay, so good job, everybody. We said that Tn equals 2 times our ratio would be 3 over 2. So term 2 divided by term 1. So that's 3 over 2 to the n minus 1. And that was part A. And then in part B, we would have subbed in. So term 15 is 2 times 3 over 2 to the power of 15 minus 1, which is 14. And we all got the same answer of 583,86. So remember to round correctly to 2 decimal places. When you say, why can't I multiply 2 with 3 over 2? What you've got to do is you've got to multiply 2 with 3 over 2 to the power of 14. So you can multiply 2 with 3 over 2, but the problem is that iPhone, you've got to obey the laws of BODMAS. So you've got to raise this base. Remember, the base is 3 over 2. You've got to raise that base to the power of 14 first, and then multiply by 2. Okay, so you can't multiply 2 by 3 over 2 first. We've always got to obey the laws of BODMAS. I hope that answers your question. Okay, all right. Cool beans. Okay, so now we are working backwards. Do you think that you could do this without me telling you how to? You're working backwards to n, so it asks us to determine which term in the sequence is equal to 80. So in other words, what they are doing here is that they are implying that Tn is equal to 80. They're implying that A is equal to -1. When they say to us which term of the sequence, they are implying we need to calculate what n is. All right. Okay, so if n says yes, go for it, guys. Let's see you work backwards and see what you come up with. Nice. So a lot of you have got 28 as your answer. Okay. All right. So just double checking on that. Hopefully we all said 80 is equal to -1 plus n minus 1. And in this case, our difference was 3. So we ended up with 80 is -1 plus 3n minus 3, which means that 3n is going to be equal to 84. All right, when we take the -1 and the 3 over to the other side. And so n would be equal to 28. Okay, good job, everybody. Well done. We're all cool with that. So just checking in. Is everybody happy so far? Is it all making sense? Thumbs ups. Yes, we're all smiling. Oh, good. Good, 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 good. Okay, you guys are great. Well done. All right. Nice. Yay. Okay, Big V, if you want to ask a question, you're welcome to unmute. I'm going to go on to the next thing, but you're welcome to ask. Okay, so Stephanie, remember the difference is term 2 minus term 1, or term 3 minus term 2. Okay, so 2 minus -1 is 3, 5 minus 2 is 3, 8 minus 5 is 3. Okay, so this pattern is arithmetic. Okay, there's going to be a constant difference. Now, we can apply the same idea, so this idea of working backwards to geometric sequences. That's fine, no problem. So what I wanted to do is I just wanted to point out a couple of things to you that you probably already knew, but we need to make sure that we can solve for n when it comes to exponential equations. All right, so if they give us the equation that 64 is equal to 2 to the power of n, how would we solve this? What method do we need to use? What have our teachers taught us to do here? Okay, so if you haven't done logs, that's it. Okay, you will be able to use logs eventually, quite right. But the idea is to make the bases the same. Absolutely. Okay, so our clue is we need to write 64 as 2 to the power of something. So in this case, 2 to the power of n is equal to 2 to the power of 6. Okay, now that we have equated the bases, we can equate the exponents. Very, very, very important, guys. When you are doing this in maths, you must show this step. You've got to show the step where you equate the bases. All right, and then you're going to work out what your answer is. You cannot skip that. Absolutely. Now, what happens? Now, this is an interesting situation because we never really deal with negative bases until it comes to exponential or geometric number patterns in matric. So what if we had a situation like this where we had -2 to the n? We cannot make it into +2. All right, so we've got to keep it as -2 to the n. So we've got to do the same thing on the other side. We've got to take it as -2 and we've got to raise it to the power of 6. Now, do you see, even though our base is negative, our answer is positive? And that is because we have an even exponent. If our exponent was odd, we would have a negative answer. Okay, but it's very, very important that when you make the bases the same, they are in fact identical. Okay, and here we would still end up with n is equal to 6. Are we all cool with that?
Ma'am,
Yes, Katlego.
can you make an example where the exponent is odd?
Okay, so if I had something like this. Okay, but now there's going to end up being, there's going to end up being a problem because, actually, is there going to end up being a problem? Okay, so now, if I do, this we can't solve. All right, this we wouldn't be able to solve because if I now do this, okay, so it would have to be that. Because if I'm going to take a negative base and I'm going to raise it to a power that's odd, I'm going to end up with a negative answer. I cannot end up with a positive answer. All right, so now I would end up with n being equal to 5 in this case. All right, so that's what I mean. Are you happy with that?
Yes, ma'am. Thank you.
Okay, so Offense and iPhone, what is it that I have confused you or you're not 100% sure on? No, the -2 doesn't go to the other side, iPhone. Okay, so remember, you are solving exponential equations by making the bases the same. Okay, we're not moving terms from one side to the other. What I'm doing is I'm rewriting 32 with a prime base. Okay, so, but in this case, I've got to use -2. All right, so once I've equated my bases, I can then go ahead and go and equate my exponents. Okay, like so. The capital signs. Offense, what are capital signs?
Offense, you can also unmute and talk to us so we can understand what you mean.
Okay, ma'am, by A, ne, we have 64 minus 2 to the power of n. But
Yes.
then when you solve, there was no negative in front of the 2.
No, absolutely. So what this example is showing you is that you can either have a base that's positive or you can have a base that's negative. What I was trying to get at is that if your base is negative, you've got to make sure that you've written it as a negative over here and over here. If your base was a positive, then you've got to make sure that you write it as a positive over there and over there. Okay, so in other words, what I'm trying to say is if you are answering this question over here, you cannot go 64 equals -2 to the n and then say 2 to the n equals 2 to the 6. This is incorrect. Okay, so in other words, you've got to be accurate like that. Okay, that's all I was trying to get at. Okay, so now somebody's already worked this out. That's very good. Well done. All right, let's see you guys work out D. Good, well done. Okay, so yes, Amina, good. Lasedi, yes. Ayanda, I'm doing it here on the left-hand side for you. So the first thing that you need to do, Ayanda, remember you want to isolate the base. So the first thing that you need to do is divide by 2 on both sides. Okay, after I've divided by 2 on both sides, I now want to make my bases the same. So now on the left, I've got -1/2 to the n. And on the right-hand side, I need to work out what 1/256 equals -1/2. And then I've got to work out what that exponent is. Now, you can't do that on your calculator, but if you press the fact button, so in other words, you press 256, press equals, and then press shift and then fact. And your fact button is above the degrees, minutes, and seconds. And you'll see your calculator will tell you that 256 is equal to 2 to the power of 8. So here your exponent is 8. So we're going to write -1/2 to the power of 8. Now that we've made our bases the same, we can equate our exponents. So n would be equal to 8. Okay. What are we always expecting when we get an answer for n in number patterns, matrix? What is n equal to? N has to always be hang on a second. There's a couple of you that are, so this is a bit difficult because there's some of you that understand perfectly and then there's some of you that are struggling to understand this. Okay, so hang on a second. Not just positive Boitumelo. Okay, n has to be a natural number. N has to be a natural number. Okay, so this is why I'm saying to you guys, you have to go and practice your grade 10 and grade 11 work, okay? Because these questions that I'm doing here for you, these are not matric questions, okay? This is stuff that you would have learned in grade 10 and grade 11. So you've got to make sure that you go and you practice this so that you understand how to do it, okay? All right, so if I lost you for question D, I'm just going to go through it one more time.
Sorry, I just came back in because of my load shedding. Could I
That's
please see
fine, Yolanda. No stress, no stress. Okay, so you've got 1 over 128 equals 2 times minus 1 over 2 to the power of n, and we need to solve for n. So we need to isolate the base. So that means that we've got to get rid of this times 2. So the opposite of timesing by 2 is dividing by 2. So 1 over 128 divided by 2 is 1 over 256. You would do that on your calculator. All right, so now 1 over 256 can be written with the base minus 1 over 2. All right, so on your calculator, you can work out that 256 is 2 to the power of 8. So that means that 1 over 256 is 1 over 2 to the power of 8. So making our bases the same, minus 1 over 2 to the power of 8 is equal to minus 1 over 2 to the n. The bases have to be the same. Okay, and therefore n is equal to 8. Remember, n has to be natural. Okay, it has to be a counting number. All right, are we feeling a little bit better now? All right, and then I see some of you are giving answers for the next ones already. Okay, which is nice to see. Well done. However, okay, so now let's talk about equations involving odd or even exponents. Right, so in question A, right, if r squared is equal to 9, then that means that r is equal to 3 or r is equal to -3. All right, so there's more than one answer in this situation. Okay, and over here, if r cubed is equal to 27, then r has to be equal to 3. I'm going to take the cube root on both sides. Here, I'm going to take the square root on both sides. Now, let's have a look. If I say that r cubed is equal to -27, what is r equal to? R is equal to -3. That's quite right, because -3 times -3 times -3 is -27. Good job. Okay, and in D, will there be more than one answer? Yes, there will. Okay, so when our exponent is an even number, our answer can either be positive or our answer can be negative. That's it. Good. Well done. All right. So here, R will either be equal to 2 or R will be equal to -2. Okay, so remember when your exponents are even, there's more than one answer. Remember when your exponents are odd, there's only one answer. Okay, so these sorts of questions come from grade 8, grade 9. We just got to make sure that we can still do this work when we get to matric, because we're going to apply it in the questions that we're going to do. Okay, so now let's have a look at this one. All of this was leading up to this. This is a geometric sequence, and they want us to work backwards to n. The question says determine which term in the sequence 4, 12, 36, 108 is equal to 8, 7, 4, 8. Right, so now you are going to have to work backwards to work out what n is using the examples that we have just gone through. Okay, so you need to establish A and R, sub in Tn, and work back to n. Okay, so you just wanted me to explain how you got D. So you're taking the fourth root. Remember, 2 times 2 times 2 times 2 is 16, or -2 times -2 times -2 times -2 is positive 16. Okay. No, you don't have to do it. When you say simultaneous, this is not a simultaneous equation over here, because you're not solving for more than one letter. You know what A is, you can establish R, you know what Tn is, you are then calculating N. So let me help. Do you want me to help you with the first step? Oh, wow. Okay. Okay, so they've said this, if you don't need me to help you with the first step, you go right ahead and do it. Determine which term in the sequence. So when they say which term in the sequence, the implication is we need to solve for n. We know what A is. All right, A is equal to 4. You need to work out what R is. You know that A is equal to 4. You know that R is equal to, you're going to work that out. N is what they're asking you to calculate, and they're telling you that Tn equals 8748. So now I want you to substitute into your formula and work out what N is. Okay, so a lot of you are getting N is equal to 8. I'm just going to wait and I'm going to just see that. Okay, R is equal to 3. Sure, well done. Okay, so hopefully we all did this. We all said that 8748 is Tn, and it's equal to A, which is 4. R is 3, so it's 12 divided by 4, or 36 divided by 12. That's 3 to the power of n minus 1. So the first thing that we've got to do on both sides, how did you get R is equal to 3? Remember, R is equal to term 2 divided by term 1. Or you can say that R is equal to term 3 divided by term 2. It is the constant or common ratio. Okay. So now, no, it's not Londeka. It's term 2 divided by term 1. Okay. Rama, what's the next step now? After I've made 4 times 3 to the n minus 1 equal to 8748, what do I need to do to both sides now?
Can everyone mute, please?
Yeah, can everyone mute, please? There's a lot of extra noise coming in. Thank you. Rama, what must I do on both sides now? That's it. So see how you've got the right idea. I'm going to divide by 4 on both sides. So if I take 8748, guys, please mute. I'm going to end up, thank you very much. I'm going to end up with 2187 is 3 to the n minus 1. I've then got to write 2187 as 3 to the power of something. And using my calculator, I establish that it is 3 to the power of 7 is equal to 3 to the power of n minus 1. So that means that n minus 1 is 7. Now I'm going to take my 1 over to the other side, and that means that n is going to be equal to 8 in this case. Yes, absolutely, Onatile, 100%. Okay, how are we
Ma'am?
feeling it? Yes.
I just wanted to know, ma'am, how do you like find the answer without having to multiply 3 by itself so many times? I don't really know how to use my calculator, so.
Therefore, I'm not 100% sure what it is that you're asking me.
Like, ma'am, when you want to know, 2,187, ma'am, like when you want to
Yes.
simplify it and make the root.
Oh, so when you want to write it with a prime base.
Yes, ma'am.
Okay, all right. So what you will see, I must actually download my emulator. What you will see on your calculator is a button that has a circle, and then it has like an apostrophe, and then it has 2 apostrophes next to one another like this. And then above it, it says that. On my calculator, it is in the 3rd row. It's the second button in the 3rd row. So you can activate this function over here, which is the factorizing of a number using this button. So what you would do is you would take 8748, or no, sorry, in this case, it would be 2187. So you press 2187 and you press equals. So now you've got 2187 on your screen. You then press shift, this button over here, the fact button, and then your calculator tells you that it's equal to 3 to the power of 7. It does that for you.
Okay, ma'am, thank you.
That's it. Exactly. All right. Are there any other questions? No? Are we all good? All right. That was all that I had prepared for today. We finished a little bit earlier than what I sort of had anticipated. It's obviously a bit difficult if there are some of you that are struggling and then other people are really right sort of ahead of the stuff. What you must maybe consider then is which class you want to attend, because the class that we do from 5 to 6 moves a little bit slower, and then this class from 6 until 7 moves a little bit faster. So I just want to let you guys know going forward that we are going to be moving a bit faster if you attend this particular class. All right, Shailene, you said you've got a question. Go for it.
Can I also have?
Good evening, ma'am. I know that we're not on this topic, but ma'am, I wanted to ask for your help. I wanted to ask ma'am, how do you find the nth term for the quadratic sequence?
Okay, so when you're finding the nth term for a quadratic sequence, you've got to use those rules 2a, 3a plus b, and a plus b plus c. So I don't know if you remember, we had done this the last time. Let me see if I can go back and find something. Yeah, so in other words here, in this particular question, was 75 was our first term, 53 was our second term, 35 was our third term. In 2.2.2, they want us to determine the nth term of the number pattern, which was quadratic. So it would be in the form Tn equals an squared plus bn plus c. So we would use these rules that I've written on the side over here. 2a equals 4. So you've got to work out your first differences, your second differences, and then use those rules. So in other words, sorry, I'm speaking very fast right now, but if you've got 75, 53, 35, 21, you're going to say 53 minus 75, which is going to leave you with negative 22. And then if you say 35 minus 53, that's going to leave you with negative 18. And then here you would end up with negative 14. So there's your first differences. Your second differences, you're going to end up with 4. So this is what happens with quadratic number patterns. So then we would take 2a and make it equal to 4, so that we get a is equal to 2. We would then take 3a plus b and make it equal to negative 22. So 3 times 2 plus b equals negative 22. So that means that b would be equal to negative 28. And then we use a plus b plus c, and that's equal to the first term of the pattern, which in this case is 75. So that's 2 minus 28 plus c equals 75. So C would be equal to 101. Okay, Shailene?
Yes, ma'am, I understand. Thank you.
Okay, no problem. Then there was somebody else who also had a question. Okay, Amina, she asked it. That's fine. Let me just find. Big V, you've got a question?
Ma'am, can we attend both the classes?
I must be honest with you, I don't know. I'm not sure what the policy is with that, but I can find out for you.
Okay, ma'am.
Okay, and then I can let you know. All right. So I see you also saying here, can you have other questions to practice? Okay, so this is something that I think we need to develop a little bit more at Watobe, because often there is this request for extra work. So let me speak to the people in charge, and I will try and see if I can maybe at the end have some extra questions, and then I can show you the questions, show you the answers, and then you guys can come back and practice it and mark your own work. I think that would be one way. Or would you prefer something that was emailed to you? I don't know. What would work better? What do you
Yes,
think?
with the answers also.
Okay, so you would want something that was emailed to you with answers as well, so that you could mark it. Okay. All right, that's fine. That's something that I can definitely go and speak to them. Yes, so in Koneza, this was just an introduction to both. Next time it is going to get harder. Okay. All right. Anyway, there's the